Um, okay, my name is Ketheesan. I'm a fellow of the Royal Society of New South Wales and a staff member with the University of New England. As an immigrant to this country, I acknowledge that the sovereignty of the lands that we now call Australia were never ceded. We gather today on the traditional lands of the Anuan people to share knowledge and our concerns about our future of all communities. I am honored to introduce today's forum, which explores the vital concept of One Health, the recognition that human, animal, and environmental health are inextricably interconnected. Today's theme is One Health for a Changing World, forests, farms, and families. So, as I've already alluded to, we are trying to integrate these approaches that recognize human, animal, and environmental health are in fact interconnected. So I want you to look at this painting, which I found in Urala. That's our UNE Aboriginal Center, which the Aboriginal Center celebrated its 40th anniversary recently. The central circle here represents the self, surrounding arches represent the families, friends, and the community. Yeah, and the interconnecting lines that you see represent all that surrounds our connections to land, our culture, our spirituality, our kinship networks, and so on. These connections form the foundation of our resilience and capacity to navigate life. And of course, when these connections are weakened or severed, it impacts on our well-being and causes suffering. So One Health, in fact, embodies the same principle. The health of individuals, communities, and ecosystems are fundamentally interdependent. It is, quite simply, an ancient concept. But of course, now we wrap it in modern scientific language. I now invite Lorina Baker to share what oral history, ancestral knowledge tell us about One Health in the context that of this community. Thank you.
Before I begin, I'd like to also acknowledge the traditional owners on whose country we gathered this evening, the Anuan people. I'd also like to acknowledge their neighbours, the Gumbaynggirr, the Gamilaroi, and the Dunghutti, who shares the caring of this country. So I come from a vast network of kinship from that spans what we call the corner country, which is north eastern Flinders Ranges, the Adnyamathanha people, across to the vast Darling river system, to Burke with the Murrawarri and Wankamara people, and up to Queensland, so the Kunya and Cooma people. So I've got a vast network. And when I was invited to speak, I thought, how do I fit our knowledge systems into Kethee's diagram? And I thought this is the only way I can talk about One Health is into our songlines and tell you a little bit about how important our songlines are to us and our knowledge systems. So the Murra is the centre, the songlines of our country, this country they call Australia. It's made up of many nations. across this vast network. So Mura is everything, everywhere. Time is now and all at once. It is the deep knowledge, history and culture of this continent that is translated and culturally expressed in song, story, dance, art and language, and many other cultural forms. The Mura interconnects people to their ancestors, the spirit beings, and to country in an interdependent, symbiotic kinship system, creating a healthy country, healthy people, a healthy and recognised knowledge system. To know and experience the Mura is to awaken from the colonised slumber we all have been in, to see the Aboriginal world that surrounds you. So to give you, so the term songlines, you might all know and understand songlines. It was coined by Bruce Chatwin in a book called Songline, 1987. It's similar to the term dreaming that was coined by anthropologists Baldwin Spencer and Frank Gillen in the 19th century. Both these concepts were used by researchers and writers in an attempt to understand and explain our knowledge systems and our ancestors' great Mura tracks. So the ancestors and spirit beings created country. They laid down the law of the land and gave us our languages, our identity and our sense of belonging to our parts of our country. Country is the land, the water, the sky, and it is also the law, our customs and our cultural practices, language, places and sites. Country is everywhere. We belong. Country sustains us and ensures our continued survival as nations peoples, as it has done for over 65 years and counting, and will continue to do so well into the future. So if you think about First Nations people, that's who we are, our identity, our family, our vast network of kin, and our sense of belonging to our country. And so you might wonder why or how we get One Health, and if you recognise our knowledge system beneficial, the interdisciplinary nature of Indigenous knowledge systems, and how that best can be used then in all aspects of Australian society, in education, health, employment, for the betterment and One Health, not only of Aboriginal people, Indigenous people in this country, but for all Australians. And so it also, if you look after country, country will look after you. And I guess that's my, and how do you engage that in research? And I haven't got my diagram because we were only permitting one diagram. So what we call the Mura is our is everything to us. It's also me, my vast kinship network. So if you apply the Mura in research, then it's all the Indigenous cultural and intellectual property that applies when you work with Indigenous peoples, with Indigenous communities about Indigenous knowledge, and the responsibility we have, being reliant and trustworthy individuals, being respectful of our knowledge systems, be recipient to give back, to ensure that our research is beneficial to the communities in which we've been working with, to recognise the deep knowledge and to listen, to sit. And so Mura is also the diri to that, what it takes to acknowledge and be respectful and recognise the knowledge that our elders have, and you'll learn from them directly. And the relationship, so everything we do is relational. So the original One Health diagram, that also makes sense when you apply it to our science. Thank you.
We'll leave the questions for later. Thank you very much. And I think we have next, and we are really privileged to have Professor David Durrheim, the Director of Health Protection at New England Health, with us today. He's an internationally accomplished physician, researcher, and most importantly, as far as I'm concerned, a passionate advocate for equitable global access to effective public health measures. Professor Durrheim will illustrate how zoonotic diseases affect our communities and regions. he has established in our region a network. Some of us belong to that. This represents a significant contribution to integrated health as a model for the whole of Australia. So over to you, Professor Durrheim, and thank you for driving all the way from Newcastle.
Thanks.
Thank you.
Thank you very much. Unfortunately, I have more. I was allowed more than one slide, so it's a tremendous privilege on Ngunnawal country. I want to pay my respects to elders past, present, and emerging, and congratulate you on a great initiative. It's great to have an evening to talk about One Health. I love that diagram, that interconnectedness between people, animals, and the environment. And you're absolutely right. The Western culture actually only started talking about One Health in the 1960s, way beyond, long time after First Nations people recognized the concept, and they thought we'd invented it, and then it went nowhere because it's philosophically everybody said yes, it must be that way. But no one could operationalize it. So I'll be talking a little bit about how it's been operationalized. Which of these devices is actually working? Oh, the old-fashioned one. Okay. There we go. So it's highly relevant that we're talking about One Health when the world is frozen at the moment by a public health emergency of international concern, which was 2 weeks ago. This is in the Democratic Republic of the Congo. And it's a zoonosis that is causing this problem. So the Ebola virus, the Bundabuja virus, and if you're very, very illiterate, you could try and say that 5 times quickly and see how you do. You could trip yourself up. But it's a horrible virus. It's spilt over from flying foxes to people in this region. There is mining, there's incredible civil unrest. There are over 200 warring factions in this part of northeast DRC, and yet it's not remote. And this is why this is a real issue this time. There are wonderful highways all the way down to Kampala, and obviously people have already traveled, and there's been export of the virus to Kampala. So you've got a virus that quietly lives in foxes or bats, which has got into the human population, and where there is distrust of health services, and there's political unrest, and there are 200 warring factions, and there is a lust for the mining, what's coming out of the mines, things can go horribly wrong. Now, when we think of One Health, we think about the natural environment, but actually in public health, and we often think about the natural environment being critical, but other environments being just as important: the political environment, the economic environment, the social cultural environment, the technological environment, and all of them have contributed to the situation in the DRC. It's probably been circulating for at least a month. So we're about a month behind the virus, a good thing. And in an area where people do not trust the health services, where isolation facilities have been burnt to the ground because people are really angry, and where there's incredible distrust of government. And this has been, many people are believing this is simply just a rumor. This isn't going to go away very quickly. So it's probably good that we're thinking about One Health, because it can have dramatic impacts like this. That's the area that's it could easily spill into South Sudan. And all of you that know anything about Africa know that South Sudan is probably more complex than northeastern DRC, but it's already spilled over to Uganda. The death rate is less than we would expect. So there's a huge undercount of the number of people. And the tragedy, and I will be on a call a little bit later this evening, because I serve on a SAGE committee that advises the Director General on vaccines for Ebola viruses is that we don't believe that there's any cross-protection offered by the vaccines that are currently available for other strains of Ebola. So on that sobering note, I've got your attention at least. Now that's always controversial. The minute you put up the climate change, but New England is progressive up here, so you can deal with that. But again, look, there's no question that we're seeing an impact of changes in climate on infectious diseases. And the next slide, I'll use two examples of types of diseases where we are seeing just a very measurable change. The problem are the projections, and the projections are very interesting actually, because they really depend upon pathways that we choose. And so the modeling that's been, and this was published only last week in Nature Medicine, a really interesting bit of modeling, is if we do just what we're doing at the moment and don't change anything, and our choice of social pathway is one of not collectivism but individualism, where we basically plunder the world for its fossil fuels and we change nothing in terms of equity, we're very likely to head on the red pathway. The interesting thing is that we can probably plateau if we choose to do this as a collective. Healthy nations actually do really of marvelous renewable energies. It's still going to have an impact, but it's not going to be as dramatic an impact as the worst case scenario. We are already starting to see, even locally, the impact of vector-borne diseases. So Japanese encephalitis never occurred in southern Australia. It crept in during the pandemic when we all were rather distracted, and we haven't got rid of it. So now every season, in Armidale, you're lucky, you've got a little bit more altitude. But if you go down the hill to Tamworth and the rest of New England, Japanese encephalitis is now a feature. It's not going away. Now, why did it emerge? Why did it stay? Why, after literally decades and decades and decades of being free of this virus, which only affects the far North Queensland and the Torres Strait, is it actually emerging in southern Australia and now as part of our array of infectious diseases? More worrying is dengue. Dengue is a very nasty virus. It has 4 different types, and if you get infected with the one type, you're probably okay. It'll be nasty. It'll be like Ross River. You'll get aches and pains and joint aches and so on. The problem is if you get another dengue strain, so if you had 1 and then you get 4, it can make you really, really sick, and you can get basically a hemorrhagic type picture, start to bleed like the people with Ebola, or you can actually get a completely catastrophic shock syndrome and can't be rescued. So you don't like, dengue's terrible. It occurs where Ketheesan and I used to be. We spent 3 years together up in North Queensland, and I was doing tropical medicine up there. And it occurred occasionally up there, but the predictions are that it's very likely that it could come further south, and that Australia won't be able to get rid of it. And it may not be there for 12 months of the year, but it may well be that we may be receptive for 4 months of the year. So that's not a really bright future. Do nothing about what we're doing at the moment with climate change. And the reason is every aspect of the life cycle of the mosquito is affected by humidity, temperature. It bites more when it's warm. It breeds better when it's warm and moist. It reproduces very effectively, and the sticks are around for much longer. So here you don't get bothered by winter because they all die. But if it's a little bit warmer, like it is on the north coast, they can see mosquitoes right through the year. So the possibility of something becoming established is very interesting. Other diseases, environmental diseases, obviously natural disasters. We're seeing many more natural disasters. Natural disasters and infectious diseases go hand in glove. And nasty things like cholera can heaven help us, let's not have cholera in New England. Now, my first brush with, I'm going to take you on a journey to Southern Africa. My first brush with One Health occurred very close to this beautiful area. This is a low-felt area, very close to the Mozambican border, where there is the tail of a wonderful mountain range called the Drakensberg, causes a large plateau. And this area is called the escarpment. And I just got back from doing I left neurology, sorry, Chris, and went over to the UK and I studied public health medicine over there. And Nelson Mandela then was inaugurated as president, and I was one of the people they recruited back to run the communicable diseases programs in states that had been newly created. And that was exciting and was just so inspiring working in that environment. But I was just back about 35 years. Got a call on a Friday afternoon. And in public health, when you get a call on a Friday afternoon, it's sort of, you get an adrenaline surge. Something's going to happen. Friday, we call them Friday afternoon specials. And it was the chief vet, Paul Kluck. And Paul said, Dave, I think we've got a problem. And I said, oh, tell me what. And he said, well, one of my state vets went out, found a dead cow next to the road. It was bloated and was oozing blood from all of its orifices. I won't go into detail. And he did the right thing. He took it from the ear, took it back to the lab. He stained it. It's anthrax. He went back to go and discard the carcass, which he absolutely burned to ash, and the carcass is gone. And in this sort of environment, when there's a carcass, it's food. So Paul and I set out afternoon, went as far as we could in his four-wheel drive, and then we went through the bush to the nearest village. And yes, after explaining what had happened, it had been prepared, but probably ill-prepared and undercooked. Fortunately, I'd taken along, I thought I was very well equipped because I thought, got to take doxycycline. I took a lot of doxycycline along, and I was doling out doxycycline. Once we said to people, look, that you saw how the cow ended up, do you want to end up like that? And no one wanted to end up like that. So everybody wanted their doxycycline. So that was a brush with One Health. What I hadn't realized, and we were very proud of ourselves, we came back, and on the basis of that, Paul and I and a lab person who'd been involved set up a One Health network. Now, we didn't know it was a One Health network. We just realized that if vets and medics and the lab didn't work closely together, we couldn't actually deal with these issues. So that was an important thing. The other thing that I learned, unfortunately, the long grass that I walked through, either on my way to the village or on the way back, I picked up a passenger, which I didn't discover until a week later when I got the worst fevers, the worst rigors. I was quite delirious. A blimmin' amblyoma tick had found the little groove between my buttocks at the back. I'm like Patrick Mason. I'm a survivor of a tropical disease. So I got myself a good dose of African tick bite fever. Rickettsia africae is the name of the particular pathogen. And for those of you who were very observant, you would have noticed 2 white rhinos and a couple of wildebeest. There you go. So that was my brush with One Health in Africa. And everything that we tackled, we didn't call it One Health. We just did it in partnership because that's the way you had to deal with these things. So very interesting coming to Australia, and people spoke theoretically about One Health. When we were up in James Cook, they were talking about One Health. And I said, but what are you doing about it? And everything is in pillars. And health doesn't speak to DPI unless there's a real crisis. And no one speaks to the wildlife people because they're feral. And ecologists are weird people. And people keep to their little lane. And this was very strange. So this is a fascinating paper that was published in Lancet Planetary Health, because to try and make it more practical, people thought, well, maybe we can actually create networks and force these people into a room and then maybe they'll actually work together. And the idea took off quite slowly. This was very interesting. So this was by 2017. There were about 100 of these networks globally. So there were 100 groups that could be found in literature and the grey literature working together, just 100. This was very interesting. This was sparked by the West African Ebola outbreak. So Ebola really sparked interest because people realized, wow, we're going to have these spillover events because of various social and climatic issues, and we really have to tackle them together. The interesting thing is that these networks they did some very valuable things. They shared some data, and they thought that they were learning about each other's fields. But other than that, they didn't do very much. When you get to the things that were actually practical, like responding to emergencies, only 5% of them did that together. Even research, and that's strange, only 40% were doing research. When you see that government were the large stakeholder and academia was the second largest stakeholder, and they weren't even doing much research. So that was the whole ecosystem of these networks when that very interesting study was published. And then the Lancet in 2023 ran a virtual series on One Health. And one of the things that they looked at is the one thing that seemed to be sustainable, that seemed to actually operationalize the concept of One Health, were these networks. And so they did a review, and Matondo and colleagues had a look. And across the world, there were now 184 of these networks, so it had almost doubled. The tragedy is that 25% of them were no longer actually active. They'd had a short life. It was largely because they were project funded, and then the project funds dried up and they died. The same sort of composition, mainly government and academia, almost no people with an ecology background. Anthropologists and social scientists were as hen's teeth, and First Nations people were almost never represented. So it was the same old stodgy academics and government, but the other people who played in this area weren't actually given the opportunity to participate. You'll see that Europe was very red, and that was largely because there were funding. There was the European Union actually acknowledged that this was a really important thing and provided funding for a lot of these One Health networks, and so it took off. But in other parts of the world, they really didn't take off very well at all. I think we are that dot. Our regional One Health network is the one dot that was, it's fortunately things have actually got, the idea has now really expanded in Australia as well. So now we'll bring you home. So this you should, Hunter New England is the patch that I look after. Nearly 1 million now residents in the area. About 200,000 come from outside, first generation Australians, Indigenous people. This is, our First Nations birth cohort is larger in Hunter New England than the Northern Territory. That's how important First Nations people are actually in this part of New South Wales. And it's a big it's a big geography actually. It stretches from Lake Macquarie all the way to the Queensland border. And it's a very beautiful part of the world. And I don't need to tell you about how wildlife and agriculture and the equine industry and humans interact. I mean, it's just the way that we do life. And those bloomin' feral pigs. But we'll talk a little bit more about feral pigs. Some people live for feral pigs. I hate feral pigs. And I don't farm. I see the disease impact. So came down to initially it was Hunter and then became Hunter New England. And Pete Massey, and those of you who work in health might know Pete Massey. He was up in the New England Public Health Unit and they joined with us, and I became the director across the two. And Pete had some very nice, really nice partnerships with agriculture and with vets. And we just realized that if we were going to be meaningful and have very functional relationships to respond to outbreaks in particular, that we really needed to have a ongoing relationship with people. And it started small, and it just seemed to grow. It was mainly ourselves and vets and Department of Primary Industries initially. But the universities heard about it and they thought, oh, gee, this sounds interesting. That's a real nice dynamic. So they wanted to get involved. The laboratories were very interested and got involved. And it was very interesting to see how we were able to pull human health laboratories and veterinary and environmental laboratories into it. Epidemiologists, entomologists, the people who love mozzies, biologists, social scientists were attracted as well. And we just set up a way of sharing experience. It's just something that would happen 4 times a year, generally 4 times a year. 90 minutes was dedicated to it. And between times, anything that was interesting was shared by email, generally. So at those meetings, we generally asked the human health, the animal health, and the wildlife health to talk about what they were seeing, their surveillance, what gathering data on, and share that. We did some joint exercises, which I'll give you a few examples of. We even ran a few face-to-face meetings, which was fun. Most of this is done virtually because we spread over such a big geography, and the reach has gone. It was very interesting. There are now these little subsidiaries, but people would get to hear and they'd join from Queensland, and then we get a speaker from Victoria and they'd say, Robert, I want to be part of this thing ongoing, and people would migrate, and it just grew. And we always spoke about emerging risks. So about if you've got a partnership, so you saw it was established in 2000 and it's still going strong 20 years later. So we must be doing something right. And I'll talk about my reflections about why I think we did what might be going right at the end. But in terms of outcomes, these are some very tangible outcomes that this One Health network was able to achieve. The first was getting shared public messaging. So communication, government does communication really sometimes quite badly. A classic example was around hantavirus. And the paranoia that drove that response and the media was probably because government didn't get on the front foot and really talk about what the real risks are of hantavirus spreading between people. Now, you say, but it spread on a cruise ship. Well, if you ram a lot of people into a sardine can, everything can spread that is transmissible. You know that we have cruise ships coming into the port of Newcastle. I'm not even flagged. So if they've got outbreaks on board of respiratory illness or gastro, they're meant to flag that to us as a port of entry. But the trigger level is only above 5%. So they expect that 1 in 20 people on the cruise ship is going to be and unable to leave the loo with norovirus infection through the whole cruise ship. That's just what cruise ships are. So I apologize to anybody who loves cruise ships. You won't see me dead on a cruise ship because it is just a wonderful environment for spreading it. So if you ever get an emerging virus and you want to know how transmissible it is, I'll just throw it in. Send the person onto a cruise ship and you'll see. So we would have, and our chief health officer, until things got in New South Wales, would have done simple home quarantine for these poor folks who had this horrible experience of hantavirus on this cruise ship. We could have managed that. We would have made contact with them every day, make sure they were well, given them something to measure their temperature, and had plans to how we could isolate them and manage them if we needed. But communication got in the way. Hantavirus, it's going to be the next pandemic. It's going to take off in Australia. And there's a we as well, we'll lock the whole lot up in some remote part of Western Australia. Crazy. So what we started to do is bounce our media releases off the group so that when the vets were speaking or EPA was speaking or health was speaking, we were actually speaking with the same language, and we'd all agreed it beforehand. Such a simple thing to do, but it made life so much easier. There was always a lead, but often the media are smart. They go to somebody else because they want to hear a dissonant voice. But everybody's saying the same thing. Well, then they convey an accurate message. We started to help each other with each other's outbreak response. The first one, believe it or not, was anthrax. So Australia has an anthrax belt. It's got a very interesting history. So the Port of Sydney, in 1839, the first anthrax-affected stock came into the Port of Sydney, and obviously went up the stock routes, went up the coast, went up the Hunter Valley, and then went out into the good grazing country out west. And it's got endemic. So this area, the thing about anthrax spores, this biology is wonderful. These things are indestructible or largely indestructible. To get rid of anthrax spores, they're the perfect bioterror agent. Grignard Island, which is off the coast of Scotland, they threw these. This was during Churchill's time. They thought this might be a useful agent for warfare, and they dropped a whole lot of anthrax spores on this island, and the sheep were all out. And they went back every 10 years or so, and they did soil sampling, and they still found viable spores for decades. 70 years later, there were still viable spores on the island. I mean, they're indestructible. So that whole area is called the anthrax belt, which includes Moree, which is in this patch. And every now and then, when there's disruption, very dry weather, some cow will get infected and will die of anthrax. But the last time that there was any anthrax in the Hunter Valley was in 1999. And then suddenly over Christmas, and this is the other thing, if it doesn't happen on a Friday afternoon, it generally happens on Christmas Eve or Christmas Day. We got this call from a friendly vet, and it was Paul Freeman. And Paul said, Dave, we've got a weird thing. We've got a whole lot of cows that have died of anthrax in the Hunter Valley, very close to Aberdeen, across, I think it was about 18 different farms that were affected. And it was over a very short period of time, there were 53 cattle and a horse that had died of anthrax. Now, why after 1939, 60, 70 years of no anthrax did anthrax suddenly emerge? We know the spores are indestructible, but why now? And why over such a wide, it was over 50 kilometers that these animals were scattered. So these are the beautiful things when you take a One Health approach to things, is that you get these weird questions. And it all coincided with, if those of you can remember all the way back to 2007, a 100-year rain event in the Hunter Valley with 300 mils of rain after drought, after 10 years of drought, 300 mils of rain in 3 days. Everything that was topsoil was washed into the Hunter River. And what happened is, with all of that topsoil and other layers of soil being washed off, we think that spores that had actually been concealed for decades were now exposed at the same time, simultaneously, over geography. What was interesting, people said, oh, no, it was washed downstream, but actually most of the first cases were downstream cases and not upstream cases. And there was no imported cattle from affected areas. So working together, health and veterinary science together, we tackled this particular outbreak. I put it on because it was the first one. We've done so many since then. We've discovered things about interesting, look, we have diseases in Australia, another bat disease, Hendra virus. Now, you don't want to get Hendra. There are a few viral infections you don't want to get, and one of those, if you're a human, is Hendra virus. And you don't want to get it if you're a horse either, because if you're a horse, if it doesn't kill you, and it's a horrible death. They get encephalitic, so they get brain swelling, they get overwhelming fluid in the lungs, and they die a horrible death. But if they don't die, then they get euthanized anyway. So about 100 horses have died because of Hendra virus. There have been 7 human infections, of which 4 people died. So you don't want to get Hendra virus. That's a tough case fatality rate. But Hendra was thought to only occur sort of in North Coast and all the way up to North Queensland until, we should never have thought, because if you, how is Hendra? Well, it's a bat flying fox disease. So where do flying foxes occur? Well, they occur in all of this area here. So why would Hendra be isolated to that area? But everybody said, no, it's a North Queensland, northern New South Wales, North Queensland issue on the coast. So we were doomed to have a spillover at some stage, and we had the most southerly spillover, about 300 kilometres, that occurred near Scone. And that really reset. And that was, again, an investigation that we did with bat ecologists, with environmentalists, with vets, with human health people. And then later we involved anthropologists as well. We shouldn't have been surprised when it occurred there. Now, what was very interesting was the response, though, because at that point in time, when we went into all of that, and that's all equine stud area, the studs had an uptake of the Hendra vaccine in the horses of about 20%. When this occurred, and they should have known at some stage it's going to happen, suddenly vaccine coverage jumped to 80%, and on the most expensive studs, you weren't allowed to bring animals on or off if they were not vaccinated. So it changed completely the entire vaccine history of the Hunter Valley. And then we found a different type of genotype 2 in bats over the country. They're dotted in South Australia, Victoria, New South Wales, Queensland, even up in far Western Australia. But there were no horses that had been impacted. So people said, oh, well, then this is less infectious. But when you look genotypically, if you looked at the genotype of this virus, it was almost identical. And surprise, surprise, between Lake Macquarie and Newcastle, in an urban environment, we got our first genotype 2 confirmed case. So if we'd read Nature, we would know it would have happened, but no one in that area was vaccinating their horses at all. They thought, this is an issue of far north. This is not an issue, never going to come down south. The interesting thing is that if you're finding it in bats all the way around, it's inevitable that it will spill over to horses when it's come into contact. How does it spill from bats to horses? Anybody know? In their food. So where people put troughs in shaded areas so that the animal can, first of all, you don't get evaporation of the water if it's a water trough, and the animal can eat their food in the shade. Where do bats have their colonies? In the top of the shaded areas. The bats poo and pee, all goes into the food, and the animals get infected. How do you stop this? Well, you either vaccinate the horses, the vaccine's very effective but quite expensive, or you move the troughs away from where the bats are. Sort of good One Health thinking. Not wrong, it's just One Health thinking. Okay, so we've worked together on outbreak responses. Then we've done joint exercise. The responses only occur every now and then. So you've got to actually prepare for the next response. So if we haven't had a big response that we've had to respond to together in a year, we look for doing a joint exercise. Just make sure we don't lose the practice, that we're ready to respond the next time. And we've done joint after action reviews. So after either an incident or an exercise, we learn from it by doing a debrief. And this was interesting. We did Australia's biggest pandemic exercise. Every ED in Hunter, New England was tested by dummy cases of pandemic flu strain. I think we triggered the 2000 and the swine flu pandemic because the previous year we'd run Exercise Forrest Gump. And you may ask, why on earth was it called Exercise Forrest Gump? There's a famous quote from Forrest Gump, which is when you open the box of chocolates, you never know quite what you're going to get inside. So it was a great thing, but they put this up as a particular exercise. This guy, Kevin Cooper, is an extraordinary veterinary epidemiologist, emergency. There's no one in the health field who's as good as this bloke. So he was a part of the response to foot and mouth disease in the past, to Newcastle disease when it affected the Central Coast. And so we pulled in the best person, health-related issue, because really it's the same issues. It's control, it's all about communication, it's all about coordination. So when we bring in the best resources from each other's fields, then we do these things much better. We've also try to foster collaboration around research, and it's always nice to see the sort of array of people on the publications when we do this work. I mean, those of you who are in academia, you know that to publish, but it's actually often, I love the research that you do where you learn a lot outside of your own field at the same time. That's the fascinating stuff. And this is where we've started bringing in social scientists, because we have health messages and then we wonder why the public don't do what we tell them to do, or advise them to do, or encourage them to do, or plead with them to do. Why don't they do it? And it was very interesting. So we tell people, don't go near the bats. Don't touch the bats. They're going to scratch you. And bat lyssavirus is just as nasty as Hendra virus. We had our first New South Wales death 18 months ago, a guy on the North Coast in his 50s who was scratched and bitten by a bat on his front porch. 3 deaths up in Queensland. We know that the virus is widespread. Up to 10% of flying foxes, or the big fellas, at any one time can be infected. And if you do broad community swabbing, 1% of flying foxes will actually have the virus, about 0.1% of microbats. So you're playing with fire. This is a bit of Russian roulette if you go handling bats, because they naturally scratch and bite you. They don't like being handled. So we went investigating with a social scientist and spoke to people who'd recently been bitten or scratched by bats. And it's got something to do with I think, the size of those eyes. You know how mothers are so attracted to their babies. Babies are ugly. They're grossly ugly. All the guys are nodding and all the women are shooting me daggers. But they've got these beautiful eyes. And there's something about the size of the eyes, I think, which just warms the heart, particularly of women, but men too. And look at those eyes. And now all of you who hated bats before tonight, you're looking at those eyes and you're thinking, geez, that's a beautiful animal, isn't it? But it's very interesting when we listen to people, they really were worried about the welfare of animals. They try to rescue them. Some people even knew that there was a risk. They still wanted to rescue them. How could you leave this animal languishing? And it was in the heat, for goodness sake. I've got to free it from the fence. It's stuck in the fence. It's in the heat. So we changed our messaging. And we said, if you want to do the right thing by the animal and really improve its chances of survival, call somebody who knows how to manage it safely, because you're going to do it harm. Now, that hasn't stopped all of our bat exposures, unfortunately. We're busy, those of you, anybody here in the health field, Hunter New England Health, SDPR, single patient digital record. It happened overnight last night. We're changing, we're the first health district that's changing to this sort of one-size-fits-all patient electronic system. And of course, in the middle of all of this, somebody with a bat exposure came in as well. Now, they were well managed, which is good. But we had to change our messaging, and that was the right thing to do. The other thing, we actually involved an anthropologist in this work. We went and we spoke to people, both the vets and the horse owners, about their experiences of Hendra. And it's amazing. I mean, as much as people are attracted to bats, a horse is part of the family. It's quite extraordinary, the affection that people have for a horse. And if you tell them you go away from your horse and they can see it's languishing or it's about to be put down, they're not going to stay away from their horse. So how do we actually make it as safe as possible? So this is not about removing all risk. This is about actually making the risk manageable. And some of the feedback that we had, Kiralee Thompson led this, and who's an anthropologist, was quite extraordinary, the level of affection, but also the trauma that the vets had to deal with. Vets don't deal that often with people who are in absolute trauma because they're losing a loved one. And it felt these as very traumatic experiences as well. So we share our surveillance data. I said that's the top item when we get together. And we've done that with emerging infectious diseases like equine chlamydiosis. And that was very good because it causes, so this infection is a form of psittacosis. It actually causes terrible fetal losses in the horse population. So you can imagine in winters like Tamworth and Scone and so on, they hate this particular bacteria. But we were worried because there was a outbreak of respiratory illness in a veterinary college, and it was never confirmed as psittacosis. But so we actually put a specific surveillance program in place as a collaborative thing, and we found fortunately that there was no risk. But this is interesting. These feral pigs. I hope there's no one here who's a feral pig, goes hunting. You look far too civilized, to be honest. You don't hunt feral pigs. The way to do it is not with a gun. You don't waste bullets. You do it with a dog and a knife. Okay, so yeah, you can see this is an academic, and this is not Tamworth. Okay, and definitely not Moree. So part of the joy is hunting the animal with a dog, and then actually taking it out with a knife. And so there's blood and gore and stuff everywhere. The problem is that most of these feral pigs have got brucellosis. It announces itself in the male in a very ungainly fashion. And it was a Queensland problem, but it has spilt over across the border and it's spread dramatically. And you can see there the data from dogs, and these are almost all hunting dogs, is amazing. But what's very good is that the messaging, the vets have been amazing in getting the messages to the owners about what they do with these dogs so there's no spillover, because brucellosis is not fun. It's a nasty, nasty infection. Most organs can get it, and if you're pregnant, you can lose your little one. So it's not a great thing. But what's interesting is we wondered how it had spread so quickly. In just 5 or 10 years, it spread from way up on the Queensland border to around about Singleton. And we think it's spread on the back of hunting utes. So what happens is, it's terrible. Hunters go out, they come from the coast, they go and shoot the pigs, they the piglets, and they go and put them in their local bush area. Because then you don't have to travel so far to go pig hunting. Anyway, all right, so that's surveillance. We review each other's policy documents, again, for consistent messages. We've offered student placements across disciplines, which is fantastic. We've learned a lot from students from other disciplines. It's wonderful. We share incident alerts, and particularly we share expertise. And this is probably quite timely. Unfortunately, the mice are on the move again. And what we're seeing in South Australia and Western Australia is now starting to emerge in New South Wales too. But it's amazing when you pull together economists, pull together social scientists, pull together psychologists, there are a few in the room, pull together public health people, veterinary people. If I was taking only a human health interest, this would be all I'd be interested in mouse plague. I'd be focused infectious disease on leptospirosis. It's nasty. It's spread through the urine of rats and mice. If it gets into cuts on abrasions or into mucosa, you can get a really nasty infection. Kidneys can pack up, your liver can pack up, and your brain swells and you die. So it can be a very horrible thing. There were 100 cases of leptospirosis during the mouse plague. But that's my narrow infectious diseases perspective. The bigger impacts were not 100 cases of leptospirosis. They were the destruction, the catastrophic destruction of crops. The mental health issues were horrendous. People were too scared to go to sleep because they sleep with their mouth open and they didn't want to wake with a mouse in their mouth. So it was pretty horrible. The economic impacts, the destruction of entire stores, groceries destroyed. And then when we started using rodenticides to control the plague, of course they spilt into other species, wildlife species and so on. And so it caused absolute chaos. So you approach these things. And so there were town halls that were held with multidisciplinary teams to talk through the mental health issues, to talk about baiting and rodent control. And that's really the way to do it. You must tell me if we're getting at time. Not yet. Not yet. Okay. We decided that, look, it was going well, but could we do it better? So we ran a survey and we got a pretty good, and you're getting about a third of the active participants actually responding to a survey. That's a good sign. So we were happy with that. There was a lot of experience, multiple disciplines in the group. But what could we do better? What was going well? Well, we clearly had broad representation across lots of groups: wildlife, ecology, environmental health, cross-cutting across multiple. Most people found it a useful experience being involved, that it was providing them with relevant information. They thought that it helped them with outbreak response surveillance and research. It hadn't contributed as much as I'd hoped to policy change, but anyway, that seems to be a little bit of a sticking area. And then there were some very nice comments in the free text fields where people said, I feel valued. And that's great. If people feel valued, that's a really good sign. They'll keep participating and hopefully bringing something of themselves as well. They gave us some really great ideas about how we could do it better, because people often in the field, they couldn't get to every meeting. They support them. Oh, well, that's sensible. Put it on a team site where we can share our stuff instead of via old-fashioned email. Make sure that we get great nations involvement. We were just like the global networks, the ones that I pointed to in that Lancet series. We weren't engaging, and so we had a face-to-face, which was purely First Nation led, and First Nation knowledge in the One Health arena is just extraordinary. And we are learning an awful lot about how taking that knowledge, which is generations old, and actually bringing it into the way that we think, which is fantastic. And then they also said, don't overreach. Keep doing what you're doing. Don't kill this thing by trying to actually milk it too hard, which was very good. So I'm getting to that age where I maybe have too many grey hairs and ask me occasionally to come and speak about leadership and things like this, and that makes me worried, because it means I'm somewhere coming slightly towards the senile side of things. But anyway, I took a moment to reflect about why I think this network after 25 years is still going strong. And I think it is about multidisciplinary, and it's about each of the disciplines actually understanding and valuing what the other disciplines bring to the table. And I think that's what really makes One Health very, very special, is understanding, yep, I've got something that is precious to me. It's the area I'm specialized in. Somebody else has got their areas, but we're so much more. We're more than 1 + 1 when we bring it together. It multiplies what we can add. I think that respecting others' expertise, I see that in action, and it's great to see. I think the areas that wildlife we've always had strong, but only in the recent years has social science really shown us the importance of social science and anthropology, and those insights. I think we've really learned a lot. And in the most recent 2 to 3 years, First Nations input as well. These things aren't sustainable unless you're prepared to invest. So one of the roles that the biopreparedness epidemiologist on my team, her role is just coordination, thing she does, because it won't just happen. Don't actually invest in it. So that's been something I've been able to at least contribute through a very skilled resource. You should be both proactive and reactive. I think that we've shown that with some of the research that we've done. When we've asked for feedback, we've tried to respond to it. And I think this is a real key too. When government sees something, and New South Wales, what we've done, and then they said, we've got to replicate this in Sydney. And they try to do it in a very structured, we'll create One Health branch. But who owns the One Health branch? And it doesn't work. So there's something about keeping this organic that actually does work. The minute you try and lock it down and say, we will create this pillar, maybe it won't work so well. So it's going to be very interesting to see. So the new Australian Centre for Disease Control has a One Health branch. They're trying to do a bit of a grand experiment. Can they? It's stuck within. It would have been stuck within health, but because it's in an independent, what's meant to be an independent organization, it may have some chance. So it'll be very interesting. They participate, so they're both observers, and they have participated in our regional One Health network. So I'm hoping that experiment works. It'll be great if they can pull that off at a grand scale and give an example of how it can work in government. But for the moment, I think one shouldn't kill a regional One Health network by bureaucracy. So I just want to thank you. It's been an absolute delight to share some of reflections, some of the stuff we've done. It's been great fun, to be honest. And thank you for involving me in this event this evening as well. Thanks, Ketheesan.
Thank you. Thank you, David, very much. You guys have enough time to ask questions. And what I to say is that thank you for taking us to virtually every continent and every state as well. Next up, I would like to invite Sue Wilson, who is a researcher in environmental pollution at UNE. She leads an investigation into microplastics pollution and its environmental consequence. Your work is focused on microplastics, and your work reminds us that whatever we had often comes to haunt us as far as microplastic goes, that is real. Please share why your research is so important for this concept of One Health. Thank you.
Thanks very much, Ketheesan. Thanks for inviting me to talk. So yes, I lead the pollution science team research at UNE. So I actually have to really thank the head of school who appointed me 15 years ago and appointed me as an academic, an environmental pollution academic, some colleagues said was the most depressing title they'd ever heard at that time. But these days now, environmental pollution is one of the top 3 threats to our environment as identified by the UNFAO to human health and the environment. So we're right on the mark at the moment, and UNE having an environmental pollution professor is great. There's not many universities that do. So yeah, at UNE, my group, we study a range different pollutants, their effects, how they behave in the environment, their sources, and how their effects can be mitigated. And 2 groups of pollutants that we're particularly focusing on at the moment in current years are the PFAS group, the forever chemicals that you've all seen in the media, and also microplastics, because both have emerged as really significant concerns in the environment and for exposure to humans, but we really don't understand the total consequences of what we're being exposed to at the moment. So we're working on a range of projects. Most of my projects in microplastics are focused in terrestrial systems. We've done some work on running trails and how our shoes deposit microplastics through these wilderness areas, also agricultural systems, and we've got some new projects with new academics at UNE looking at microplastics in koalas, and also we're going on a trip to Christmas Island to check out the microplastics there. So we've got a wide range of projects, but the groups of chemicals, PFAS and microplastics, have been in my arena of environmental scientists of exceeding what we call planetary boundaries, which are basically critical processes that we need globally that regulate our system. And both these pollutants have been identified as exceeding those boundaries and interfering with the processes so that global processes can't sustainably operate, and are exceeding our capacity to manage the pollutants. They're right outside the atmosphere, basically. So coming to plastics as a whole, so plastics are the most wonderful and terrible invention, really. Now I know, having worked in the area for a number of years, they're durable, they're long-lived, and we use them in every commodity and activity in our daily life, and we can't do without them. And there are areas where we won't be able to get rid of them, and we shouldn't. But really, since the 1950s, we've produced over 9 billion tonnes of plastic, 80% of which has ended up primarily as waste. Only about 9% has ever been recycled. It's ended up, a lot of it, in the environment. Plastics persist in the environment, and there's a range of negative effects. They're obstructive to systems, to water, to soils, the macroplastics. They break down and fragment to microplastics, small particles less than 5 millimeters in diameter, and nanoplastics. And these smaller size plastics can get to parts of the environment or a human that the larger macroplastics can't get to. So in addition to the physical particles that cause inflammation and irritation and blockages, they also release chemicals. And we know that there are about 16,000 different chemicals that are associated with plastic and that we are exposed to if we're exposed to plastics, 3,000 of which we know are hazardous. The other multi-thousand we just don't know yet, but we're exposed to them. They're stabilizers, they're flame retardants, they're in production. So in addition to the physical particles, we have the chemicals, but plastics also, and particularly the microplastics, there's little TARDISes and transporters of other pollutants in our environment, like metals and PCBs, and act as transporters to receptors too. So there's a massive issue with microplastics in our environment, and they actually pervade all our system. They pervade the air, they're found in the poles, in water systems, in soil systems. In fact, they think in ag systems, we have 23 times more plastics because of mulching and things than we actually see in the oceans. Everybody knows about the issue in the oceans. There are bodies, they're in our brains, they're in our beer, they're in our blood. We all have them in our system, and many of us scientists in our labs have tested our blood just to see if we've got plastics in our blood, and we do, and also the chemicals. We see many of the chemicals in our blood and our urine. What's it doing to us? We are exposed, for sure. A range of adverse effects we do know about. It cause inflammation. The chemicals have potential to cause cytotoxicity and damage DNA, but really we don't know. That's almost every group similar to mine is working on microplastics, as our health people, as our ag people. They transport into plants, they move through ag systems as well. So microplastics, we know, pervade, and other pollutants pervade, and particularly the persistence like PFAS, they're in the same category, cross a myriad of environmental boundaries. And we can't talk about One Health without talking about the pollutants and the cross-disciplinary nature of us all having to talk together. So that's it from me, Ketheesan, and thanks for inviting me.
Thank you very much, Sue. That was wonderful. So just keep those questions you will have to ask. And the next speaker is actually a friend of mine who, for some strange reason, prefers the title, what's it, Passionate Foodie. Though in my opinion, she's a better researcher than a chef. Gal, your research into gut microbiome, fermentation, and sustainable food systems has profound implications for how we think about health and food systems. So I know that you like to talk a lot, but in 5 minutes, could you please give your insights into your work and as far as One Health is concerned? Thank you.
Thank you, Ketheesan. That was a wonderful introduction, and also very contradictory to how you send me home to cook dinner every day, family. All right. Here we go. Yeah, so what I want to talk about today with One Health and the food system is actually focused on one aspect of it, which is the presence of antibiotics. So imagine a world where you can't use antibiotics, you know, where a paper cut can be fatal. I can't imagine that. I grew up in a world where antibiotics is always there, always count on it to treat anything. But we're seeing more and more cases of resistant pathogens. And there are many contributing factors, and most people think, oh yeah, we just use doctors prescribe antibiotics quite a lot. But actually, most of the antibiotics used today are actually coming from agricultural systems, so about 70%. And sometimes they're used to treat disease, but most of the time they use either as preventative measures or as growth enhancers. So this is quite a dangerous practice because what we know about microorganisms is that they're extremely adaptable and extremely resistant. And the other thing that we know, and David showed that today as well, is that they stick around very, very long time. So any microbe that developed the resistance doesn't really leave the environment. They're a little bit like your plastics. They're just there. And then at the right opportunity, they will flourish. And when they do, they will be resistant to the treatment that we have against them. Another thing about resistance antimicrobial resistance that most people are not really, like, it's a little bit hard to grasp because we say the resistant transfer, but it's basically genetic material that transfers and confers the resistance. And with microbes, they have this remarkable ability to transfer genetic material without actually having to be of the same species. So it's just there. And sometimes it just stays, like DNA would be in the environment and microbes will be able to grab it and grab the resistance. Some of the research we did looked at what happened in soils that are near big feedlots or soils that have been treated with compost. So the way the cycle works really is if the animal is treated with antibiotics, it will then secrete it to the soil through excretion. From there, it can basically go anywhere. The soil, the water around it, the food that we eat, if the animal itself is the food that we eat. So what we looked at was the prevalence of antibiotic-resistant bacteria in soils surrounding the feedlot compared to soils that are further apart or soils that have been treated with compost from the feedlot compared to untreated soils. And the results were very conclusive. You have far greater resistance near the feedlot or where you treat it with compost. And these results to farmers, and they were like, but we don't use these antibiotics. But the thing is that there is historical use. And this historical use remains within the animal and it remains within the soil. And it's something for us to consider and to deal with, and it impacts everything in a really One Health way to describe it. All right, thank you.
Thank you, Gal. So having studied this subject for some time, Gal has got rid of this from her diet. She has turned a vegan. Yeah. So there you are. So the next speaker is Jackie Epps. She's a research academic and a rural general practitioner who made some very interesting observations on leptospirosis, an infection previously confined largely to North Queensland, where I myself spent most of my life and still go there often. And why, if you may think why we are stopping this at before 7:30, because I would like to see the state of origin, the maroons beating the blues. This leptospirosis now sort of occurs here as well. So, Jackie, what does this emerging pattern tell us about One Health and the climate and so on? Please, over to you.
Thank you very much, Ketheesan. Just to note that I'm a rural GP academic who's probably slightly obsessed by infectious diseases, but I know I'm in the presence of a One Health infectious diseases public health physician guru. So thank you for your patience today. Okay, I want to start with a question. How many of you have heard before today of leptospirosis? Okay. How many of you know someone who works with animals or on a farm? Or someone who's lived through a mouse plague or a flood? Right, okay, so there's a lot more hands there. That gap between who is at risk and who actually knows about leptospirosis is what we'll talk about today. Leptospirosis, as you've heard, is a bacterial zoonosis. It's spread through urine of infected animals and entering humans via floodwater, contaminated soil or broken skin. Mild cases can mimic the flu, but severe cases, as we heard, can cause organ failure and death. I'll draw your attention here to figure 1 on the left, thanks to Almazar and colleagues. Leptospirosis is, in every sense, a disease at the intersection between animals, the environment, and people. It's your quintessential One Health disease. Lepto has been long considered disease of tropical North Queensland, and certainly there's been many cases there. However, my research team, including colleagues from James Cook University, has been analysing 20 years of Queensland Public Health leptospirosis notification data, statistical modelling that accounts for rainfall, years, and how rainfall effects have changed over time. I also flag here that this is still preliminary unpublished data. What we found was quite striking. Compared to someone who lived in Brisbane, a person living in far north Queensland is around 15 times more likely to contract leptospirosis per capita perspective. But the most extraordinary finding was outback Queensland. A person living in outback Queensland is over 30 times more likely. Now, these differences, and this is important to specify, exist after we've already accounted for rainfall. So our model mathematically removed the rainfall contribution before calculating the regional differences. So that far higher risk in outback Queensland because it rained more there. It exists above and beyond whatever rainfall those regions experienced. It likely reflects structural things like the cattle and the feral, the nature of the work, the landscape. Rainfall is an additional risk factor on top of all of that. And this brings me to the rainfall story. For a long time, the link between severe wet weather and leptospirosis was assumed, but not rigorously proven in Australia. Our team has now formally modelled this relationship for Queensland, moving from we think weather drives this disease to here's the data that proves it. In this graph, the blue bars, which might be hard to see from up the back, are human leptospirosis case notifications, plotted against rainfall totals from the preceding 2 weeks, so those orange lines. Every time that orange line spikes, you see the blue bars rise in response. This is not a one-off. It repeats consistently over 20 years. Our data, with this graph, but also much further data, shows us that the relationship between rainfall and leptospirosis is real and consistent. And that is why a future with more intense and more frequent rainfall events, which is what climate projections are telling us to expect, is likely to be with more leptospirosis. So what does this have to do with New South Wales? Well, leptospirosis is not new here. It's been around for a long time. But our Queensland data gives us a clear warning about what happens when structural risk meets increased rainfall. Outback Queensland carries about 30 times the per capita leptospirosis risk of Brisbane before a drop of rain is factored in. Now, significantly more rain, and this graph you can see shows you exactly what rainfall does to case numbers. Consider inland and western New South Wales. The conditions are remarkably similar. Cattle and sheep, lots of feral pigs as we saw, loads of feral and wild animals, agricultural workers. The disease is already present. The question is, what happens to that established baseline if climate change delivers significantly wetter conditions to regions that have typically been dry? This graph gives us a clue. A 2018 New South Wales outbreak, where 84 workers at a single berry farm on the north coast were infected, was unusual. It was a specific high exposure event, not necessarily a signal of a broad southward march of the disease, but it does show what leptospirosis looks like when conditions align. A workforce with lots of cuts and scratches, rodent populations and wet conditions. And these ingredients potentially can exist across rural New South Wales. As we just heard, rat and mouse transmission is now the most common route of leptospirosis, human leptospirosis in Australia. The Arborea subtype, or what we call a serovar, barely in 2000-2001, now accounts for the highest proportion of confirmed cases nationally and was responsible for that berry farm outbreak. Australia's recent and ongoing rodents are forecast to recur. When you combine a plague or really wet season with horticultural workforce harvesting by hand, with cuts and scratches, you've got a bit of a perfect storm. However, we are probably missing lots of cases. Leptospirosis can look a lot like the flu. Without a high index of suspicion, clinicians may not think to test for it. Typically very underdiagnosed, the real burden of disease in Australia would be much greater than our notification numbers suggest. The last study of how this infection actually is in the Australian population was conducted 15 years ago. We have called in our research for serosurveillance, population level blood testing to find out how many people have actually been exposed in the past. This is different from counting actually diagnosed cases. It tells us the true footprint of the disease throughout the community, including people who are infected but never diagnosed. Until we do that, we're making decisions of disease that we cannot fully see. We're only counting the cases that we happen to find. So what does all this mean for New South Wales forests, farms and families into the future? Our community may be at risk in places or ways that are not yet fully on people's radars. It means that doctors in regions that have rarely seen leptospirosis cases may need to start thinking about it. And it means that our surveillance systems, the way that we monitor and detect this disease in humans and animals, needs to be sensitive enough to detect change, not just account what we already expect to find. Leptospirosis is already here. The question is not whether it will revive. It is whether we'll recognise it when conditions change and whether we will be ready. This is the gap that we need to close together using a One Health approach. Thank you.
Any questions? Or I'll hand over the mic to anyone who I think should. You have a question.
Thank you. Very nice presentations, all of you. So I have two questions especially. So you said about animal-human interaction, right? It's been there for ages now. If you don't consider the percentage or the p-values, there were more interaction in old ages than now, right? So because now the detection rates and notification are high, is it because due to a One Health approach or due to the new technologies available?
That's a great reflection. It's a combination of things. I think one of the things we need to recognize is that human populations are putting a lot of pressure on the environment. So we often in the past, bat colonies were nowhere close to where humans were staying. In the Greater Newcastle area, the largest bat colony is in Blackbutt Reserve. Now, Blackbutt Reserve is a place where humans, it's completely surrounded by some very nice suburbs. In fact, it's very close to the John Hunter Hospital. So there are lots of doctors that live around Blackbutt Reserve. It's a very popular, there's a weekend fun run in Blackbutt Reserve. There's a wonderful wildlife centre and a bird centre where everybody takes their kids. So we've actually brought the animals very close to humans. The same thing particularly with development. So the Port Stephens area is effectively a marsh area. It's it's the last place where they got rid of malaria in New Wales. New South Wales used to have malaria. Australia used to have malaria. In fact, it was up in North Queensland until probably only about 30 years ago. So we've recepted the area. We've got an Anopheline mosquito, which isn't a great vector, but it does exist in this area. But what has happened is that the area that was previously swampland has been reclaimed because it's close to wet areas. It's very attractive for people to live there. So people have moved into where mosquitoes flourish. They weren't there before. So we have closer, we've put pressure on our environment. I think it's a very real thing. In terms of One Health surveillance, yes, I think it has improved. So we may be detecting more. I think awareness, I think what Jackie was saying, if our primary care clinicians are aware of brucellosis, aware of Q fever, we detect more. There was Rick Spear, who was a professor of tropical medicine up in Townsville, a really amazing person. He said that his wife caused an outbreak of syphilis in the Northern Territory. And you don't normally say that about your wife. She's a GP. She went up there. There'd been no services provided in that part of the Northern Territory. When she got there, she said, gee, but there are lots of people here that look like they... And so she started a screening program. And so suddenly there was a syphilis outbreak, but it was all the undetected cases. So it wasn't his wife actually causing the outbreak. She found the outbreak there all the time. So enhanced surveillance is definitely a contribution. Improved laboratory, so we're detecting pathogens We've got techniques now which are marvelous, and some of them are environmental. The most reliable indicator of COVID activity in the environment, in the human communities, is now wastewater detection of viral fragment. In New South Wales, there are only sites that still do it. None in New England, fortunately. One in Newcastle at Glenrock Lagoon. But we are using the environmental surveillance now to find measles cases. So you can find viral fragments. These are such sensitive systems. So some of it is very real, but I think the impacts of climate change, particularly on infectious diseases, are profound. And it can go both ways. We've seen that some areas become less hospitable for, say, mosquitoes because they become drier, but others seem to become very, very much more receptive. So it's a great question. It's a complex answer. It's a complex field. It's a whole host of factors that are playing together, I think. I don't know if anybody else wants to respond.
Can I ask, in fact, Lorina a question? Now, I know you have been working in this space for some time. Has anyone from any approached you to work on One Health issues and how the community views these issues?
Short answer, no.
But would you like to be involved?
I guess it's probably been in this forum. I think it's probably essential. And as David explained, it's only been 3 years since First Nations people have been invited to sit at the table. So if we're invited and we're part of the discussion, we can be also a part of the solutions.
Okay, thank you. Questions, please. I have told Rukshan he can't ask his second question. So there's one here. Please.
This is more of a comment than a question, but I can personally attest to the fact that a few decades ago it was very difficult to diagnose leptospirosis because near Weipa, I was doing some research on reptiles, and I got the leptospirosis from a feral pig, and it was diagnosed as malaria, and I was treated for malaria and nearly died until one of the doctors said, this doesn't seem quite right, and they tested me for leptospirosis, and fortunately I survived.
Thank you. And Chris, you had a question?
I just want to ask if you wouldn't mind commenting on the outbreak of diphtheria in northern and western parts of Australia, particularly with reference to possible vectors and the role of low vaccination, low vaccination, and your comments about whether you think it'll spread.
Yeah, look, we don't have the whole picture of the Northern Australia outbreak of diphtheria yet. Actually, a public health physician who worked with me during COVID is currently up there. So I've got a little bit of insight. But there's some controversy, and there's obviously some binding between the feds and the territory. The number of deaths has, for example, been debated in the media, which is bizarre. What we have seen is that diphtheria, which really in a country like Australia, we shouldn't be seeing diphtheria. Because we've got very effective vaccines and they really, really work. And you normally have diphtheria, the big outbreak that caught everybody's attention that wasn't in a refugee camp or in a developing country was with the collapse of the Soviet Union. And they started seeing diphtheria. And the main reason there was a collapse of their vaccination programs. So what had been a very structured program fell apart, and there was obviously the dispersal of all of these stons, and the health systems and education system while to catch up again. We know that the rates of vaccination coverage have slipped. Fortunately, not in the Hunter New England region very much. 1 to 2% but you can't ignore that. You've got to tackle it. But it's slipped much more in Aboriginal families than in non-Indigenous families, and particularly in Northern Australia, that is a feature. So there's been a drop of about 5% coverage. What we are seeing, though, is that many of the cases are not in children, they are actually in young adults. So the question really is, did these folks, when they were in the schools, were they in attendance when they were offered a booster? We know that with diphtheria and with whooping cough, the protection that you offered is not lifelong. And so generally, that's why with pregnant women, and we'll jump to whooping cough, you give them a boost in their pregnancy. So you give antibodies to the little one when they're born, they protect it till they can get vaccinated. So we think that waning immunity may be a contributor as well in the Northern Territory, because a lot of the cases are young adults. We know that Aboriginal attendance in high school has dropped, particularly since the pandemic. It's been quite catastrophic, and that's right across the country, and that's something that needs to be tackled. So again, there are multiple contributors. We think that the drop in childhood coverage is important and needs to be addressed. That's why there's possible breakthrough, which is why they are encouraging 5 yearly boosters, and that's been implemented. They're doing a broad program offering vaccination, which has been well responded to in Aboriginal communities. So they're working closely with First Nations leaders to actually get the coverage up. For the full extent, some of it might be overdoses. So interestingly, when you swab people who've been with the case, in the household of the case, particularly if they're living in quite close quarters, they may not be sick, but they may be colonized. So you do a swab of the throat, the person may have an intercurrent cold or influenza, but you get diphtheria growing. So maybe some overdiagnosis. So it's very difficult. I think we'll get a fuller picture later, but I think there are multiple contributors to it. I think if you one's traveling up to the Territory, probably a good idea. If you haven't had a booster in the last 5 to 10 years, it's probably a good idea at the moment to get one.
Okay, there's a question here.
Thank you. This relates to the diphtheria outbreak, but a lot of the commentary that I've heard is that the spread of the diphtheria, and it is some of the people have had vaccinations, but it was the Northern Territory persists in building completely inappropriate housing for Aboriginal people. It's overcrowding, and that also relates to the spread of rheumatic fever. And there was, I can't remember the name of the program, but there was a new type of house, a test house built in Tennant Creek, which was for exactly the same amount of money, but it had all the space, it had the open spaces, but the Northern Territory government just wants to build these concrete boxes that look like toilet blocks.
No, that is a really important contributor. So I mentioned that if people are living in close proximity, the likelihood of spread is much. And what you've got Western style housing, poorly maintained, and it's widespread. The impact of housing for health programs where they've been implemented is profound. When people go, and it happens in New South Wales, they engage with community. Community actually tells them what is needed, and there's a proper engagement in terms of the house stock and the housing maintenance. It makes a huge difference. So it's quite inappropriate that the housing is a major contributor, and that's been well documented. We've seen it with anything that is transmissible, is that if you're crowding people into a house or into a structure, the likelihood of anything that is person-to-person transmissible is much greater. So you make a really good point.
Even the Darwin Hospital, which was built 20 or 25 years ago, was designed after the Canberra Hospital. And that has major flaws as for the population, several stories. Yeah, Cam, you have a question.
Yeah, look, I was really encouraged by the whole One Health and the picture you painted, David, of cross interdisciplinary sort of collaboration. And it made me think, one of the things that I'm really passionate about is we spend 12 to $14 billion a year in this country on research, and we do very little translation of that. Right across, and the only stuff, the stuff that gets most of the focus is the stuff that earns the most money, which is the therapeutics and that sort of the health and medical stuff. But even most of that still doesn't get translated. So I think what you've presented and what this movement presents is this really, and I was amazed that you're introducing social sciences and Indigenous into this sort of idea, which is taking interdisciplinary to another level. But what I guess I was interested in, just your comments, and maybe you, Lorina, because what I love about Indigenous culture is that you've had a country that survived, a group of nations survived for tens of thousands of years with multiple nations all surviving, coexisting. Whereas in Europe, they just took each other out one after the other. And I think this idea of actually accepting others and respecting others, but I'm interested in your ideas about what can science and research learn about this, and even some of the other people here around how do we do better at that? It's like you've got a model that actually works and works really well, but we've still got schools and faculties and silos that are structurally sort of inhibiting people from collaborating. So I don't know if you've got any thoughts, because you're actually in the academic sort of world, you see it, you're walking in both worlds. But any other comments around how do we do that to actually do more of this right across the whole research spectrum?
Well, to understand, probably to put it simply, to understand the continent that we live in is to understand our songlines. So they will tell you exactly what plants and animals meant to live in a particular country, what will thrive and what has survived over 65,000 years and counting. So some things just can't survive in a particular environment. And if you understand the songlines, then you'll understand the history and how to be one with the country and how to live in it, and how to look after it and how to care for it. But what the soil is like. And it's really, it is deep knowledge. And to understand the songlines is to, I could probably talk forever because the stories are so epic, and they travel the whole entire continent. So there's really epic stories, and if you truly understand and believe them, then they were real events in the deep past that they did happen. And it's a privilege and honour to be taken by First people and be shown these things, because then that's when you become awake. So when I say to wake up from a slump, it's only when you see these things, and it's only with the privilege of working closely with cultural knowledge holders, and when you get the trust. And some of that stuff we as a research team can't share, because it's been given to us with trust, but it also allowed me to be able to explain it to a much broader audience, just how important the songlines are, and why we knew what was below in our great artesian basin is because our great water snakes traverse this whole entire continent, and how it interconnects us all. So we always known what was underneath, as well as what we know what's on top of the country, and what's supposed to be there, and how we gathered for ceremony, and when we left, and how we grieve and move from place to place, and we never were in one place too long, and overused the resources and travelled our own clan territories. So we, as Indigenous people, we've got a lot to teach all the disciplines. And again, if we're invited to be at the table, then we can also be a part of the solutions in this multidisciplinary approach to One Health. I think that's the only way, as researchers and academics, given all of our resources, what we can do, how we can, as institutions like UNE, our responsibility and what we can actually give back to our communities, Indigenous and non-Indigenous communities across the country, but particularly here in the New England Northwest.
Thank you. And Cass, there is a question.
Well, thanks for that answer, Lorina. It was Very nice to hear. I guess this question is maybe towards Gal in regards to antibiotics. I suppose there's a fitness cost often with resistance in diseases and stuff like that. With antibiotics, if we were to stop using them, presumably, do we go back to them, the resistance that fall away again, such that we could use them again, say in 50 years, 100 years?
That's a really good question. I would say probably some of it, because if it's not needed, it will disappear. So there is like energetic cost for the microbe to maintain the resistance. So if it's not needed, it will disappear, but probably not completely at all. Maybe David has more knowledge on that.
You're basically putting selection pressure, and so that those that are susceptible, you wipe out the population. So what's left are those that are resistant. So we throw next generation antibiotics and we wipe them out, and then we select again for those that genetically will survive. If you stop completely, be very interesting. I don't know that anybody would be brave enough to do that experiment. Maybe over time you could potentially see them dying out, because you're right. I mean, to select for resistance, they've given up some for survival. So you may reestablish, but I don't think anybody's brave enough to stop, because the problem is in the pre-antibiotic era, simple things that we can now just throw a little bit of penicillin at would kill you. You know, puerperal sepsis, the most dangerous thing you could do as a woman was have a baby, because your chances were sort of 1 in 2 that you'd get septic, particularly if it was by doctors rather than nurses, and you'd die. So death during delivery or just after was so, and all of that's become, well, admittedly, we've got slightly more hygienic practices around birth, but things that were simple. I mean, the big issue in Northern Australia with rheumatic fever, rheumatic heart disease are completely preventable. It's a tragedy. It should not happen in a developed country. But we've got high rates of rheumatic heart disease and acute rheumatic fever infections people because they're not getting antibiotics. So that's when you withhold something which is so precious. We don't want to lose antibiotics, because to go back to the pre-Florey and Fleming time would be terrible.
I'll just add one other thing, that we still have, even if we stop in antibiotics, we would still have enough residual antibiotics in the environment, because it's not just the resistant. There's also quite a lot of residual antibiotics. So we won't lose the selection pressure.
Ryan, I'm just wondering if I could ask first, because I wanted to ask about antibiotics.
Yeah, sure.
All right. Yeah.
I wasn't, so.
Thank you. Gal, thanks for raising antibiotics. My reason for asking a question, many, many years ago, in fact, about 40 years ago, I was a research student in a lab that was looking at genetic transfer of antibiotic resistance. So it really frustrates me that 40 years on, we're still talking about the problems of antibiotic resistance. And if we took a One Health approach, and if we'd been doing that for the last 40 years since the mechanisms of transfer had been investigated, then we wouldn't have the situation that we're in. So can you possibly put a positive spin on it? Has anything changed in the last 40 years? Because my career is in a different direction. And what can we do as a One Health approach to sort of try and avoid the situation we're in with so much resistance? Thank you.
Oh, no pressure. It is very, very frustrating. And I think we've been in this race where we're like fighting the pathogen. So we develop antibiotics, they develop the resistance, way before we even realize. And then we improve a little bit. So we give the antibiotics with like a modified version or with an additional, and now it's becoming like a cocktail. I'm hoping that we're entering an era of new antibiotics. Hopefully this will be some of the promises that AI will bring us. So we haven't had successful new antibiotics for a long time. What?
Nothing. Nothing.
No, honestly, we used to think, I think in the golden age of antibiotics, they found new ones. And then they thought, oh yeah, we'll just keep on finding new antibiotics. In reality, haven't found any new antibiotics in like 50 years. So I'm hoping we're entering the next stage. There's certainly a lot more awareness now, especially in the agricultural sector, of using less antibiotics. And I think also consumers are demanding it. So maybe that's our hope.
Can I comment, please?
Can I say no?
I don't think you have that. But it's going to be a comment. The amount of money going into research not that great, right? So, yeah, you know, I did know these figures quite well, but I have forgotten because I don't check AI so often. But one of those AUKUS submarines would be enough to sort most of the problems that your question relates to. But that will be very politically incorrect of me saying that. Go ahead, Ryan.
I'm going to give an opportunity for each one of the panelists to speak here. My question is, I'm not a researcher. I'm just a lay member of the public here. This One Health affects pretty much everyone. And my question is there something that each one of you have come across, some simple messaging that you may have deemed effective for the general population, how they can change in each of your areas? Have a bit of a think about it first. I was going to give an example because just to throw back to Townsville, there's a researcher up there who was studying fibropeptidematosis, Dr. Jones, and she was, discovering these tumors researching these tumors on green sea turtles, and messaging that she would talk about when she would talk about it publicly was that if you've got healthy turtles, you've got a healthy reef, and then the disease might have been impacted from may have been impacted from runoff from the farms, and the chemicals, everything from that may have been from something else. I'm not sure, but it's a complex disease with hopefully a very simple messaging to prevent change and to prevent to get a healthier reef, healthier turtles. Have any simple messaging that you could promote to the public in each of your areas?
I might start. So I think as Ketheesan said, I'm a foodie, so I see everything with food. And I think my message is when you eat something, you actually consume their entire history. So, if it's an animal, how it was grown, how it was treated. Even if it's a vegetable, how it, you consume everything, and that goes inside you, and it has like a holistic effect.
So on that, do you or your students get involved in public messaging of microplastics?
All the time, yeah. And I can't say all of us like it, all of the public, and we're not trained. But if you don't get out there and communicate, come to events like this, video interviews, and promote, and that's to the community. But we also, I've got a student at a big conference at the moment. You've got to advocate to industry. Industry have got to take ownership too and come into the conversation, and government, and change government policy. Yeah.
Thank you. And I'm going to turn your question here and make it very difficult. He has only taken this job 2 months ago. How would you help One Health for this region?
Look, in some ways, I think I mean, universities are going through a really difficult time. They're having everyone existential crisis, thinking, are we going to destroy the universities? Like Kindle was going to destroy books and the internet was going to destroy everything. So they're all asking the question, and I think quite appropriately, the questions being asked is this transition from what are universities and research organisations good at versus what are they good for? And I think that's an appropriate question to ask. But I think what I've learned really, I'm actually quite inspired from what David shared around how this One Health moving is this ability to understand, even that little thing around understanding humans, if you're trying to get a technical message out. And I think I've been here 2 months and I've talked to dozens and dozens of researchers, all of which are incredibly bright and doing incredibly amazing work and have got really good evidence base that they can solve a problem they really care about. But we haven't been trained and necessarily equipped to work out how to actually take that into the world and create whatever you need to do to make it work. And the key bit, which David pulled up, is understanding humans. Because to get someone to take on a new technology, whether it's about how we deal with plastics, how we eat better, how we deal with leptospirosis or mouse plagues, how we and extract and embody the lessons from Indigenous cultures, the challenge that researchers have, and in fact, any domain expert has this, engineers have it really quite badly. When you know your field really well, you stop thinking about the other person's perspective. So understanding the eyes of the flying fox, that was a really great example. If you didn't understand that, then everything you tell people about this is a dangerous thing to do is going to have no effect. And so I think in terms of, I think the way that you've led the way in terms of you want to have impact from your research, you need to spend time understanding the people who you're trying to have impact with. And that's actually not that hard. It just takes a little bit of actually energy and going out and talking to, and actually not talking to, just shutting up and listening. And that's what I've spent the last years trying to work with researchers around. How do you get to ask good questions and just allow people to help you solve the problem rather than solving it for them? So the key thing I learned from a clinical psychologist in Brisbane is rather than doing things for or doing things to, we need to do things with. And if we start solving problems with the people we're trying to solve them with, then we've got at least a nice kid's chance in hell of actually having an effect, as a no chance. And so that's what I think you guys have already demonstrated. I think we can get that message out there to the broader community, with engineering and IT and even AI. How do we actually understand the people we're trying to help?
Okay, thank you. And since we need to all talk together, I'm going to ask you guys to thank all our panel members and David, and actually give Vicki Bitsika, who is our president, an opportunity also to speak and say thank you to every one of you, and possibly finish a bit early for two reasons. One, so that you can mingle and talk, and two, I could watch my team winning.
On behalf of the New England Northwest branch of the New South Wales Royal Society, I'd like to extend my sincere gratitude to our distinguished speakers. They've been amazing. I think I have much to think about. But in listening to the sequence of presenters, Lorina, you gave us a strong foundation on which to model and develop and evolve any effort that we put in place, such as the regional One Health network. You reminded us that we're all interconnected, and when we do something to one element or one person, it has a collateral effect that we need to be thinking about and to anticipate. I really enjoyed your comment about always come from a place of respect. Thank you. David, you followed on and you started off giving me clinical depression by saying to us, these are the consequences of poor communication, of disconnection, and of not building strong, trusting relationships with people. But you did manage to turn it around. So you also demonstrated what effective approach to health is. But what I found amazing was that you weren't coming from a place of, this is what the research says, this is what we're going to do. You were saying, no, it's a living program. It's going to evolve and it's going to change based on what we see. That's brave. Thank you. To our panel members, Suzanne Wilson and Jacqueline Epps and Gal Winter, you gave us specific applications of how things can work on a practical basis. Thank you. You gave us a lot to think about. And I'd also like to take maybe 3 or 4 hours to express my gratitude to Ketheesan, wherever he is. You're not going anywhere, Ketheesan. To Cameron Turner, and also to the Nova team. Your support and active involvement has made this a success. Look at what you have achieved. So finally, thank you for attending this evening. We look forward to seeing you again in the future. 2 more events coming up. And so good, drive safely and forget the cruise ships. Don't do it. Thank you.